So the other two, the sphingolipids, glycolipids, the triglycerides, they all have fatty acids. These guys don't. They're built up into complex structures, often ring structures, that come from groups of 5 carbons. And this is the material that adds it. This is like an activated isoprene. It's got, we call it isoprene because it's got 1, 2, 3, 4, 5 carbons with a double bond, branch structure. A chemist would call this part of it to the left there isoprene. In the body, we have it derivatized with 2 phosphates, chemically activated. And so it's isopentenyl pyrophosphate is the name of it. This is like a donor of 5 carbon groups. We make it through this long pathway, which starts with acetyl-CoA. This is, when we talk about metabolism, we'll see what a key element that is in our metabolism. It's at the crossroads of fat metabolism, carbohydrate metabolism, all kinds of other things. These are 2 carbon units that can be built up to make this material we just saw in the last slide, isopentenyl pyrophosphate. It can be isomerized to dimethyl allyl pyrophosphate. You don't need to know the details of that. I just wanted to show you that this is a sort of a donor of 5 carbon groups. Both of these are, these 2 isomers. We're showing them in 2 different colors, but they both are basically isoprene units where the double bond's in a slightly different position. We've got blue versions and red versions, and there are enzymes that link these together, so we now have 10 carbons, 5 that came from this, 5 from that. You can make really long chains. This is where we get like the chains on beta carotene. Looks like this. They're different from the fatty acid chains that we're used to seeing because they go like this, they go up and down with the carbon angles. But every once in a while you've got these branches that come from these guys.
Isn't that shark fat?